and welcome to our presentation entitled Materials Classification and Selection, the best material for choosing a bike frame. In this presentation today, we will be analysing 5 different materials and discussing why or why not they shouldn't be used in making bike frames in our modern society.
Aluminium is one of the most commonly used metals in the manufacturing of bicycles, being used for numerous components, inclusive of bike frames. The use of aluminium for bike frames is one of the most conventional for many reasons. One being that it has a low density, which allows for it to be formed into structures that are lightweight, making it the perfect material for a bicycle. The density of a material determines the elastic modulus. For aluminium, it has a specific weight of 2.7 grams per cubic centimeter, which is about a third that of steel. This means that with a low density, it can deform into any shape, and it can also be layered without becoming too heavy. This application comes at a great advantage where high strength and low weight is required, which is extremely useful in manufacturing bicycles, especially in developing countries. Based on Young's modulus of elasticity, the elastic modulus of aluminium is 69 gigapascals, with its ultimate tensile strength being 110 megapascals. This means it has a high stiffness. Its durability is evident as it has a high yielding strength of inclusive of 320 megapascals, and a high ductility shown with its tension strength elongation being inclusive of and more than 10%. Aluminium is impervious to corrosion as it generates its own protective oxide coating, which allows for maintenance of a bicycle structure, making it quite durable. And in addition to this, the aluminium has the ability to be engineered into a form that can be as strong as and even stronger than steel. When aluminium has been used and has been through the process of wear and tear, its ultimate strength and strain hardening will decrease quite significantly, but this allows for an increase in strain rate, which means an increase in ductility. With aluminium, budding occurs when the material is manipulated to be formed into a tube shape, with the walls of the tube being subject to change in such a way that it creates a thicker, lightweight structure, bringing forth stronger components to be used. Essentially, this process thins the center of these walls in order to reduce the weight whilst preserving the strong ends for welding point. Aluminium has displayed low cost and high performance, being especially suited for developing countries as it has an ease and safety of handling with great affordability. It is also, this material is 100% recycled, making it perfect for developing countries, as it only requires about 5% energy in order to remelt the material into its virgin state. This allows for aluminium to be reused over and over again. For these reasons, aluminium is the perfect material to be used in manufacturing of bicycle frames. It's ideal, it has a high elastic modulus, and it's resistant to corrosion.
The material being talked about in this section of the presentation is steel. Steel is a metallic material, meaning it has all the advantages and disadvantages of a metal. It is an ideal bike frame as it is exceptionally durable, highly resistant to fatigue, and is easily repaired. Its disadvantages are that it is a heavy material, which means when used as a bike frame, it makes the whole bike heavier, and is extremely susceptible to corrosion and oxidation, which is rust. However, despite steel's strength, it is surprisingly compliant, meaning it can be easy to work with and be easily molded. The main steel in question, or the main steel being talked about, is chrome molybdenum steel, also known as 4130 alloy steel. This alloy steel is used as in high-end bike frames, as it has better strength properties than normal steel does, and it is easily put into a process called budding, which makes the steel lighter, therefore eliminating the disadvantage of steel being a heavy material. The main properties or specific characteristics of chrome molybdenum steel is its high elastic modulus and tensile strength. It has a high elastic modulus of 190 to 210 gigapascals and a tensile strength of 460 megapascals, as seen in the table with reference below. This means that it is exceptionally durable and highly sustainable, and it also means that it's an ideal bike frame, as when put under a heavy force, it will deform less and it won't break as quick as other materials would. It has a high density of 7,861 kilogram meter cubed, which means it is a more solid material, meaning less of the material is needed to be used in the bike frame, reducing the cost and waste, also meaning that the material is more solid. However, the downside to this is higher density means a higher weight, which also means that the bike frame will still be heavier, even though it is put in the process called budding. It is ductile, which is surprising because of steel strength and weight, which means it's ideal for a bike frame as it can be easily molded or easily bent. And it also means that when it's exerted under a load and it deforms, it won't snap as quick as other materials would. Also, its disadvantages, however, are that it's heavy and it's also very susceptible to corrosion and oxidation, which means greater care with this bike is needed. It can't be left out in the rain, which is not ideal for consumers, as they can buy other bike frames made from other materials and be able to use it in the rain. The material is considerably cheap, meaning everyone can have access to it regardless of whether you live in a developing country or a first world country. It is easily accessed in any environment, meaning regardless of where you are, you can still access chrome molybdenum steel and use it to make bike frames. It has no drawbacks, as there is no pollution. It can be recycled and the cost is very cheap, and it is very easily used and easily molded into the bike frame, which means it's ideal as a bike frame because it's easily worked with, it's an easy material to find, it's easily bought, and it's easily recycled, which I believe is very interesting, as not many steels are, and not many steels are ductile, which is why it's ideal.
The titanium in bike frames is an alloy with other metals, typically aluminium and vanadium. Titanium has many useful properties which are highly desirable in a bike frame's design, such as strength to weight ratio, durability, resistance to corrosion, and ride quality. The strong interatomic bonding energy between atoms in titanium enables the bike frame to carry heavy loads. Its hexagonal close-packed structure with 6 atoms per unit cell allows the metal and its alloys to possess tensile strengths from 210 to 1380 megapascals. Upon impact, the bike frame will only bend as it is shatter resistant. This is because titanium has high ductility, which is an important aspect of the bike frame's design. In its pure form, titanium is highly reactive in oxygen, and it naturally develops a thin line of oxide layer that protects it from corrosion. This metal is also much more corrosion resistant than stainless steel. Out of all the metals, titanium has the highest strength to weight ratio, as it can have the same tensile strength as many steels, yet only weigh 45% of it. Moreover, this metal is also 60% denser than aluminium, but 2 times as strong. Compared to steel and aluminium, titanium has a low elastic modulus, but this means that the titanium bike frame will deal better with road imperfections, as it has a higher ability to deform in response to bumpy surfaces, leading to a more comfortable ride. While titanium has many benefits for bike frames, there is one major disadvantage which can make this material unfavorable. The cost of titanium is not cheap and comes with a heavy price of $25.73 per pound. Although titanium is abundant in the Earth's crust, the cost of energy used to extract the metal is costly, and the processing requirements are cost-intensive as well. The hefty price of titanium also means that it is not practical in underdeveloped countries where money is scarce. The largest consumers for this material are developed countries, but to increase the market in other countries, suppliers for titanium will need to produce less costly alloys. If budget were not a factor, titanium would be the perfect metal for a bike frame, as it is durable, lightweight, and would last years. However, this material is not suitable for bikes in third world countries who desire cost-effective materials as titanium is expensive both in terms of the material and in labor.
The performance of a bike is dependent on the interaction of a number of variables such as the environment and its structural form, which has an influence on its capabilities, those being the conditions that it's able to withstand and the overall experience that it provides. This presentation in particular focuses on the structural form, more specifically the frame of a bike. The standard method for determining the quality of a bike frame is through observing the material used and the influence that its properties have on the characteristics and therefore its overall performance. In the present case, the application of carbon fiber as a material to be used to manufacture the frame of a bike will be analysed. Carbon fiber, which is classed as a polymer in terms of its general composition, is made of thin, tightly interlocked crystalline filaments as shown in Figure 1. It's renowned for having the characteristics that are greatly sought after in a bike, those being lightweight and durability. Its lightweight is a result of its density, which is well below 5 at 1.75 grams per centimeter cubed. Hence, as it has a low density and density quantifies mass per unit volume of a given substance, it can be inferred that it possesses a low weight to strength ratio, which basically means that it's lightweight but it can still bear a significant load. In terms of durability, carbon fiber offers various advantages in that it has a high ultimate tensile strength, a high elastic modulus, and is corrosion resistant. With an ultimate tensile strength of 4.137 gigapascals, it's able to withstand a high level of stress while being stretched or pulled before failing. Its elastic modulus of 230 gigapascals denotes a high stiffness, as the greater the modulus, the less likely a material is to deform with the application of a given stress. The carbon-to-carbon covalent bonds within the material itself are naturally resistant to oxidation due to their bond strength, making carbon fiber resistant to corrosion. A disadvantage of carbon fiber, however, is its low compression strength of 0.57 gigapascals, which makes the material brittle. This is a result of the sheet-like aggregations within the material itself, which readily allow the propagation of cracks. But as identified, there are various applications of carbon fiber on the frame of a bike based on its properties, which make it an ideal manufacturing material. While carbon fiber offers various advantages in relation to weight reduction and durability, cost is a deterrent. Although the grade of carbon fiber has an effect on the overall pricing of it, the main contributing factor is the manufacturing of this material, which is a complex and time-consuming process. In developed countries, despite its high pricing, carbon fiber is the material of choice for manufacturing bike frames. Contrastingly, carbon fiber isn't marketable in developing countries due to the price drawback. However, it should be noted that the constant improvements in technology are enabling a price reduction in this material. Hence, the availability and affordability of this product is likely to increase over an extended period of time.
In this section, I'll be covering magnesium alloy and why it is the optimal choice for using in a bike frame. The one big factor which influences a bike frame is weight, and magnesium alloy is the perfect solution for this, as it has an extremely low density at between 1.75 and 1.85 grams per cubic centimeter. Compare this with something like aluminium alloy, which has a density between 2.5 and 3 grams per centimeter. As we can see, this is a substantial difference, and that weight reduction will help in the maintenance of the bike frame. The other factor is that magnesium alloy has a hexagonal lattice packing system. This allows it to have greater force distribution while not sacrificing any of its either tensile strength or strength in general. Not only does magnesium have an extremely low density, which allows it to be extremely useful in bike frames, it also has some other properties that allow it to be very, very durable and useful in them. For example, the Young's modulus of magnesium alloy ranges between 40 to 50 gigapascals, which is an extremely high value considering that its density is so low. The other two factors that allow it to be extremely useful are its very high tensile strength, anywhere between 160 and about 250 megapascals. The other factor that allows it to be extremely useful is machinability. With the 100% machinability, this means that it's allowed to be very easily worked and very easily molded into many, many different shapes and sizes. Due to magnesium being an alloy, it's very corrosive resistant due to the presence of chromium and vanadium within the metal. This makes it extremely corrosive resistant overall. Magnesium is also extremely readily available on the market at quite high purity, so it doesn't require any further purification. Purely on a cost basis, compared to something like aluminium, magnesium alloys cost about anywhere from $1,100 to $1,300 US per ton. Obviously, compare this to aluminium, it's anywhere from $1,800 to $2,100 per ton, and this is obviously for 99% purity. Not only for these low costs and easy purity, but due to its easy machinability, this allows it to be used extensively in both developing and developed nations. Due to it being an extremely good metal, it can be used either way, but on a developing country basis, it's very easy to use and it's also quite cheap. Due to its recyclability as well, it can also be used for many, many, many other things.